Okay, excuse me. So for chapter 11 terms, we're going to do things a little bit different. There's a lot of very complicated terminology in this particular chapter. And to be honest, not a lot of it is widely used. And so I'm going to skip a number of terms in this chapter because they're not something that even marine scientists use very much. They're useful for understanding concepts. So I would encourage you, if I do skip a term and you're curious what it is, to look it up in the chapter, but I'm not going to go into detail for probably about half of these because they're terms you'll never see probably. I mean, honestly, the only time I see about half of these terms is when I read this chapter, right? They don't appear anywhere else. Okay, so let's start at the beginning. Amphidromic point is an area in the oceans where there is no high or low tide. It's essentially no tide. And it's a unique feature that happens, I think I've seen two of them. They're not common. There's probably maybe a dozen, maybe 20 in the world. And they occur where they do because of the shape of the land around it. So there's just no tide there. Right? So I use two terms that I want you to know for this class: high tide and low tide. So we'll talk a lot about this in class, but tides are a very special type of wave that is caused by the sun and the moon and how they influence water on Earth. So I talked about this the other day in class. The way I kind of think of Earth is a solid sphere, so like a ball, surrounded in another ball of water, right? So just take like a tennis ball and imagine that tennis ball is covered in water, maybe a centimeter thick, all around it, right? It's a tennis ball surrounded by water. That's really what the Earth is, honestly. Now, what happens is the moon, which is much smaller and the sun, change the shape of that water. Depending on where the moon and the sun is and how the Earth is rotating, right? Remember, the Earth is rotating. That changes the tides. The way I think about it is if we imagine the Earth here and the moon and the sun here, the sun and the moon are pulling through gravity, right? All masses have gravity, right? Is pulling the water on the Earth. So what happens is the Earth's water is not a centimeter all the way around it, right? Remember we talked about the tennis ball, centimeter of water. What happens is that water is pulled. So it's kind of like, it's not a circle, it's kind of like that, right? These are the high and the low tides, right? So what we see on land when we walk out to the beach, if you're walking on the beach and it's high tide, you'll see the ocean is very high on the beach, right? So you might walk out to the beach and the ocean is right there, right? It's literally right as you walk off the boardwalk. But on low tide, the ocean is further away, right? So at low tide on that same beach, you might have to walk 2 or 3 minutes to get to the ocean, right? And so it looks like the ocean is kind of moving in and out over the day. And it is, kind of. But I think it's useful to think about it as the Earth is spinning. And as the Earth spins, sometimes it goes through the big part of the water, sometimes it goes through the little part of the water. Because remember that 1 centimeter of water is distorted, right? It's pulled out. So this piece might be 4 centimeters, and this piece might be 0.5 centimeter, right? This 4 centimeters, the high tide, this 0.5 centimeters, the low tide. As the Earth is rotating in that water, it's going through these different parts of the water, okay? But also keep in mind, the moon and the sun are also moving, and how they are aligned or how they are not aligned determines other types of tides. Spring tide is when the moon and the sun are in the same plane. So if you imagine the moon here, the sun here, the earth right here, right? They're all in the same plane, right? That's called a spring tide. What this means, the relevant part of this, is the high tides are the highest, the low tides are the lowest, right? So if you want to look for seashells on the beach and you go on a spring low tide, that means the ocean is really far out, right? Further away. So you get to find shells that no one else has seen, right? Because it's been underwater. But also the high tides are the highest, right? So now if you walk out to the beach on a spring high tide, the water on that spring high tide might actually be on the boardwalk, right? It's even higher this time. So that's the spring tide, when the moon, the sun, and the earth are all in line. The neap tide is when the sun and the moon are not aligned, right? Still have the earth right here, moon right here. The sun is either here or here, right? So they're not in a straight line. What this means is there's really not a lot of difference between high and low tide, right? So on a neap high tide, you might walk out and the water is, say, 3 meters from the boardwalk. You might walk out at low tide and the water might be 3.5 meters, right? So not very far. So neap tide, there's really not a lot of difference between the high and the low tide. We'll talk about that in a little bit in class. We're gonna skip over some of these, talked about those. Lunar tide refers to the part of the tide that is caused by the moon. So if you think about the sun and the moon having different pulls on the water, if you ignore the sun, just the moon, the amount that it's changing the water, that's the lunar tide. Now, you may think the moon is smaller than the sun, and that's true. But the moon is much closer to the earth. It has a much bigger effect. So the lunar tide is actually bigger than what's called the solar tide. Okay. Mean sea level. This is kind of useful if you ever go to the beach, because it's the average where the ocean is, right? So, if you got high tides, you got low tides, but the average is kind of where, not kind of, it is where the mean sea level is. We're going to talk about how tides look on land. And there's really, in South Carolina, excuse me, we have what's called diurnal tides, right? So you have 2 high tides and 2 low tides a day. So the way I think about it is you have a high tide, low tide, high tide, low tide. That's one day in South Carolina on average, right? It varies a little bit every now and then, but that's pretty much every day you pick on a calendar in South Carolina, you have 2 highs and 2 lows. Some places only have 1 high tide and 1 low tide, right? Like if you go off of Tampa, Florida, they only have 1 high tide and 1 low tide. And again, it depends on kind of the geography of where you are. Or sometimes you have what's known as a mixed tide, right? And we'll talk about these different types of tides in class in detail. But just know you get different number of high tides, different number of low tides, and it really depends where you are in the world. Talked about those. The last thing I want to talk about is tidal range. Tidal range is just the difference between high tide and low tide. That's all that is, right? So if you're somewhere, we'll talk about this in class, there's a place called the Bay of Fundy, which is has the biggest tidal range on the planet. I think I forgot how big it is. It's tens of meters. It's a big difference. So if you go out to the beach at a high tide and the tide's here, and you go out at low tide, it's here, that distance, that's the tidal range. That's the difference between high and low tide. Okay. Well, that's it for this chapter. Again, there's a lot of terms in here. Not terribly important. I'm not going to ask them on the exam. You're never probably going to see them. You won't hear them in the news. No one really talks about them unless you're a marine scientist who studies the tides specifically. Then you'll probably hear some of these terms. But unless you talk to someone who does that, those are the key points I want you to know. Okay, diurnal, high tide, low tide, neap tide, spring tide, those are the big ones. All right, so we will stop there and let me know if you have any questions.